So one of the ideas that I started out working with was a biotech idea that became my first company, Biosyntia, that I started together with two other co-founders. And in Biosyntia, we were looking at the problem of finding non-essential enzymes. Non-essential enzymes are enzymes that will not provide a survival benefit to a bacteria. A bacteria that has essential enzymes can be selected for using antibiotic resistance. You can find bacteria that then have resistance genes using a system where you remove an essential amino acid. You can select for bacteria that are capable of producing this amino acid themselves. But how do you find bacteria that have enzymes that can produce some kind of feedstock to a compound that you're interested in, but the bacteria doesn't care about at all? This was the problem that we wanted to solve. And in our case, we used a genetic switch that we inserted into the bacteria. This switch could detect the presence of the compounds we were interested in. And then what we did was, after the switch, we inserted different resistance genes, different selection markers that could be sort of switched on and off. And in our case, we then, instead of adding just the compound that would have activated the switch and allow the bacteria to survive under selection pressure, we added loads of DNA. We added mainly random DNA, and if this DNA contained these enzymes, these non-essential enzymes that could convert, let's say, compound A to compound B that we were interested in, the bacteria itself, after being transformed, would be able to produce this compound and turn on this genetic switch so that when we would add antibiotics, it would survive because it had acquired a kind of pseudo resistance by being able to produce the compound we were interested in. So in this case, we were able to enable in vivo positive selection for non-essential enzymes, which had, at least to our knowledge, not been done before without extremely high false positive rates.